You know that feeling when you get a great idea for some kind of gadget? Like, what if your coffee pot just knew to start brewing when your alarm goes off? Or, I don't know, a dog toy that automatically launches a ball. It sounds super complex, right? But what if I told you it all starts with one simple tool? Today, we're going to break down the Arduino Uno. This little board is behind thousands of inventions, and we're going to see exactly how it can turn your ideas into a reality.
Yeah, really think about it. Ever wanted to build something smart? I'm talking about a plant that texts you when it's thirsty, or maybe a lamp that gently wakes you up by mimicking a sunrise. These things kind of feel like magic, don't they? But they're not. They're just built on really simple logic. And the place where so many people start learning that logic is with this.
This little blue board, this is the Arduino Uno. And the reason it's so incredibly popular is because it was designed from the very beginning to be simple and affordable. It's the go-to starting point for pretty much everyone: students, artists, hobbyists, anyone who's just a little bit curious about electronics. So let's get right into it and start with the most basic question of all.
So what exactly is an Arduino? Well, to really get it, you've got to understand that it's not just one thing. It's actually a whole platform, a complete system for bringing your ideas to life.
See, Arduino isn't just the physical board you can hold in your hand. That's only half the story. It's an entire open source platform. So you've got the hardware, that's the board, and then you've got the software, that's the Arduino IDE. Think of the IDE as just the place where you write the instructions, the code that tells the board exactly what you want it to do. It's this combination of the physical board and the digital code that makes it so powerful and easy to get started with.
Okay, let's meet the star of the show, the Arduino Uno itself. We're going to take a quick tour of this new tool of yours, because this is the board most people start with. And the first thing you need to know about it is its brain.
That big black chip you see there, that's the microcontroller. And you can 100% think of it as the brain of the whole operation. It's the part that reads your code, thinks about the instructions, and then tells everything else what to do. On this specific board, the Arduino Uno, the brain's name is the ATmega328P. And the rest of the board is actually pretty straightforward. You've got your USB port, that's how you'll upload code and give it power from your computer. There's also a power jack, for if you want to run it on a battery. But these rows of little holes, these are the pins, and they are absolutely the most important part for your projects. This is where you connect everything: your sensors, your lights, your motors. This is how you connect your code to the real world.
And speaking of those pins, you get a ton to play with. The Uno gives you 14 digital pins. Now, what does that mean? It means you can control 14 different things like LEDs or motors all at the same time from this one little board. That's a whole lot of room to experiment and build some really cool stuff.
Okay, so we have the hardware, we have the brain, but how do we actually tell that brain what to do? Well, that brings us to the other half of the equation, the language of creation, giving your board its instructions. You give the board its instructions using a free program called the Arduino IDE. And don't let the name scare you. It's basically just a special text editor, a notepad for writing code. After you've typed out your plan, you just plug in the USB cable, press one button, and boom, your instructions get sent straight to the brain on the board. Now here's the cool part. Every single Arduino program, no matter how simple or how complex, is built on two main parts: setup and loop. Think of setup as the get-ready phase. It runs just one time right when you power it on to get everything prepared. But loop, that's the main action. That code runs over and over and over again forever as long as the board has power.
Okay, that's enough theory. The absolute best way to understand all this is to just do it. So let's dive into your very first project. This is the hello world of electronics, making a light blink.
I know. This might look a little intimidating at first, but trust me, it's super simple. Let's just walk through it. Up in setup, that line pin mode 13 output is just us telling the Arduino, hey, we're going to use pin number 13 to send a signal out. That's it. Then, down in our loop that runs forever, we have 4 steps. Digital write 13 high just means turn pin 13 on. Delay 1000 means wait for 1000 milliseconds, which is 1 second. Then, digital write 13 low means turn pin 13 off, and we wait for another second. And because it's in the loop, it just does that again and again, creating that blink. So what you just saw, that is the fundamental logic of pretty much all physical computing. It's input, process, output. In this simple case, our code is the input. The microcontroller, the brain, processes those instructions. And the blinking LED, that's the output. You've literally just translated digital code into physical light. How cool is that?
All right, blinking a light is awesome, but let's be real, it's just the beginning. The truly exciting part is that this same exact logic, input, process, output, is the key to building way more complex stuff. We're talking everything from a single light to a smart robot.
Seriously, this logic applies to everything. Instead of your code being the only input, what if the input was a button you press, or a sensor that detects light in the room? And instead of an LED as your output, what if it was a buzzer making a sound, or a servo motor spinning a robot's wheels? See? You're just swapping out the building blocks. The core idea stays exactly the same.
And once that clicks, you suddenly have a clear path forward. I mean, look, you've already conquered blinking and LED. Check that one off the list. The next logical step is to learn how to read an input from a sensor. And once you can do that, you just combine those two skills to build a robot that follows a line, or one that avoids bumping into things. See how each project just builds right on top of the last one? So there you have it. In just a few minutes, we've gone from a simple idea all the way to a blinking light. We've seen that the journey to building something really complex isn't one giant leap. It's just a bunch of small, logical steps. So I have to ask, now that you've seen the very first step, what will you create?